So here we can see what the circuit is going to look like when you arrive in lab. Over here on the far left we have the four switch dip switches. You're only going to actually need 3 of these, but all 4 of them will be wired up, so you can choose whichever 3 you want. Next up we have the 74LS04 chip, 74LS11, and then the 74LS32. So the inverter, this contains 6 inverters. It's known as a hex inverter. This one is the triple 3-input AND gate, and then this is the quad 2-input OR gate. And then over here we have the 7-segment display. And you'll notice that each one of these chips comes pre-wired with the power and ground. The power always needs to go to pin 14, the ground always needs to go to pin 7, and that's generally true for most of these 7400 chips. Certainly for these 3 that is the case. Over here on the 7-segment display, this is a common anode 7-segment display, which means that it will have the positive terminal is going to be common amongst all of the devices. Here we can see a wire that's providing the common anode or the positive power supply to the top 5 pins, and if I pull this display out, you'll notice that there's a little wire underneath here which is actually jumpering these 2 columns together, and that means that we're providing power actually to both the top half and to the bottom half of this 7-segment display. So all that we need to do is to take the inputs coming from the dip switches, send them into various combinations of these chips, and then send the outputs of those over to here. And if we want to light a segment, remember that means we have to deliver a 0 to that particular input, because a 0 is going to draw current down from the positive power supply that's being supplied here. And this is what the board looks like after all of the connections have been made and after I've applied power to it. Now the 3 switches are currently in the 0 configuration. If I flip up the least significant bit, it should show a 1. If I flip that one back down, it'll go back to 0. Flip up the middle bit, it should go to 2. Then if I flip that least significant bit up again, it should show 3. Let's see if we can do that. There's a 3. And if I turn those both off, we'll go back down to 0. And then flip up the most significant bit, and it should show 4. So given the amount of work, the amount of design, and the amount of gates and wires that are needed to implement just the codes 0, 1, 2, 3, and 4, you can imagine that the device is going to be quite a bit more complicated if it has to do a 7-segment display for the numbers 0 through 15. Of course, 0 through 9, we understand how that displays, and then depending on the chip, they'll have different patterns that they'll display for 10 through 15. Now, one thing that I wanted to draw your attention to here is that input B, or segment B, it turns out, is actually always turned on in every single configuration 0, 1, 2, 3, and 4. And so that's this one right here. This is sort of the segment B is right here. And this wire, the yellow wire right here, is actually turning on segment B. You can see that if I unplug this, that segment will turn off. So I'm going to plug that back in again. What you don't want to do is you don't want to attach that directly to a ground. Remember that a 0 will cause the segment to light. So what I've done, rather than attaching that directly to ground, is this wire is actually coming from an unused inverter chip. So what I did here was I took the input to the inverter to come from high, I inverted it, generated a low, so this wire is guaranteed to be low, and then that comes over here and it drives that segment. If we were, for example, to unplug this wire and attach it directly to ground, well then that segment would look a little different. It may not be easy for you to tell in the video, but that segment would look a little bit different than the other segments. We don't want that, so I'm going to go ahead and put it back over here to the configuration where it is always. All of these inputs now are going to be coming from the 7400 chips, so they're all going to have the same amount of strength.